Okay, I guess that's my cue to start. Hello everyone, my name is Alasdair Collinson. I work for Xenocor Technologies, and I'm not quite sure how many of you are here because my title is very similar to a talk Venkat gave earlier. Anyway, I hope you get your money's worth. Functional programming in Java. I have here on the title slide 3 questions, and these 3 questions, I'll address all of them today, but there's actually a 4th question we have to address first. When, why, and how cannot be answered without knowing what. What is functional programming? And I would say functional programming is mainly 3 things. For one, it means it's declarative. You write what you want to have rather than how to get it. Number 2, your functions are pure, which means that the output is defined only by the explicit input you give, and there is no side effect. The output, the explicit output you get, is the only output the function has. And immutability. Your objects don't change. They may be replaced, but the instances don't change. And why do we do all of this? There's one big reason why you would use functional programming, and that's readability. The intent of functional programming, or declarative programming in general, which is the supercategory that functional programming is a part of, is to make code easier to read and easier to understand. And this is important, never mind whether the person trying to understand the code is a colleague of yours or maybe you in 2 weeks. So, 3 issues, and we want to get talking about all of them. Let's start. Describe what, not how. I've prepared a project which I'm going to use for most of the talk. This project is on GitHub. You'll have the link later so you can see all of what I'll be showing you and more that I won't have the time to show you in that repository. First of all, here we have some procedural code, some iterative code. And this conference days object contains all of the talks here at Devoxx. You can download them via a REST API. I've converted them to Java objects. So here we have all of the information sorted into this object. Now, a conference day has certain slots, time slots, where you have a talk or maybe a break. And each slot has a day when it's taking place. It also has optionally a talk. And it has some other things that we don't care about. And now what we're doing here in this iterative code is we're going through each day, getting the slots from each day, going through each slot of each day, checking whether the day it's happening is on Monday, so today, and if so, we get the talk, check whether it's here, and if so, we add it to this list. And we end up with a list of all talks happening today. Possible, but explaining that took quite a while, and we want to make it easier to read that. So can we do so with functional programming? Obviously, the answer is yes, otherwise I wouldn't be showing this. So let's do that. We start with the conference days, and we stream them. So we make sure that we can operate on the separate items in the stream now, previously the list. So what's the first thing we do? We get all of the slots for this day, and after that we don't care about the conference day object anymore. So when you want to operate on every element in a stream, you use a map function. So we have a conference day, we get the slots. Wonderful. Now what we would end up here is a stream of lists of slots. And what we really want is a stream of slots. So we can improve it slightly, a stream of slots. That's maybe a bit better. And then rather than using map, we can use flat map. And that takes a stream of something and just turns it into a stream of something. So now we have a stream of slots. Next step was we want to get those that are on Monday. and we only want to operate on those any further. For that, there's the filter function, and that takes a predicate, a function that takes an object and returns a Boolean. So let's do that. Slot get day, no, not talk, get day equals Monday. Now we only have the talks on Monday left. And we want to filter again because now we only want the slots that actually contain talks. So slot get talk is present. And that's basically it, except we want all of this in a list. We can use the collect method with a prepared collector for that. Save this to a list, talks on Monday. There we go. And as you may have seen, due to this assert method, this assert statement, this is all in a unit test, so we can run it, make sure that everything still works. Looks good. Okay. Now, this is certainly much shorter than what we had here previously. This is 11 lines. This is 5 lines. And we state very explicitly what we want to happen. We want to have all of the slots. We want to have only the slots that are on Monday. We want to have only the slots which have a talk. This is declaring what we want, rather than telling it how we want that to happen. And so this is rather easy to understand, even in many cases if you're not familiar with what a stream actually is. So that's being declarative. That's an important part of functional programming. Second part is pure functions. Prefer pure functions over procedures. So I'll just... there we go. We want pure... no, that's not the one. There we go. So pure functions, as I said, means that a function is only dependent on the explicit input it gets, and the only output it has, the only effect is the explicit output. There are no side effects. So here we have our talks as a list, and this is a reduced set of the talks, the ones we selected we want to go to today. We stream them, then we calculate the length of the talk. There's a method in this class that does that, and it returns a duration. We then want that to be minutes. We average them out, and then if there's no elements in the stream or the list previously, we will return 0, otherwise whatever the duration was, and we save that as minutes. And same for the maximum duration, but we use the max function rather than average. So if we do this, what can we assume about the result? Well, I've written a few assertions here. The average duration should be greater than 0. The maximum duration should also be greater than 0, because we know that we have talks in that list. And also the average duration should be less or equal to the maximum duration. That makes total sense mathematically speaking. If we run this test now, however, we find that something's going weirdly wrong. It says expecting 81 minutes to be less or equal to 30 minutes. And if we check what line it's in, here. So average duration is 81 minutes, max duration is 30 minutes. How can the maximum be smaller than the average? That doesn't seem to make any sense. And if we check our definitions here, we don't see anything that would cause anything to happen. The calculation of our maximum should be correct unless there's an error in the JVM or something. So, this is weird. And the culprit is actually the getLengthOfTalk method, because if we go down this part here, that's fine. We determine the start time, the end time, calculate a duration. But then there's this method call. And oh dear, it clears all of the selected talks and makes me repeat this talk in every slot on Monday. So as this talk is 30 minutes long, once we've called length of talk once every remaining time that we check our map from which we got the list. But this is a copy, so this is unaffected. But this time we only get 7 times my talk. And the maximum of 7 30s is 30. So wrong result. And we didn't expect this because this gives us no indication that it would have any side effect. There are places to use side effects, and I'll get to those later. But generally speaking, if you have a function that isn't named something like show or retrieve or whatever, something that indicates that it has a side effect, try not to have side effects in your code. Okay, pure functions. Immutability. Immutability is sometimes a difficult topic, but I'll try to explain it in a way that makes sense. There we go. So here I've created a simple POJO, talks and notes, and a scheduled class, which is also a POJO, which just holds 7 talks and numbers them 1st through 7th. And there's nothing special about those. We create a schedule to hold certain talks, and then we have this test method. So we create a schedule. That's the talks we have selected. And then we say, show this schedule to a friend. Maybe our friend wants to be inspired by what we are going to. So let the friend have a look, and the friend then returns his own schedule. Now, if we check the create schedule method, we'll find that the first talk selected is implementing microservices with Jakarta E and micro profile. So we would expect when we say visit first talk of my schedule, that should be implementing microservices, etc. And the friend obviously selected to go to a different talk, and that should be the lambdas and streams masterclass part 1. If we run this, however, what happens? It tells me that my action is actually lambdas and streams masterclass. And the reason why this is happening is that our friend made a mistake. He wanted to have a copy of our schedule and modify that. But since Java isn't passed by value, but passed by reference, in these cases, he is actually modifying our object. Now, there are many ways that you could address this. A common way is to offer a way for the friend to create a copy. There's the clone method integrated into object, for example. And if you check out the GitHub repo afterwards, you will see that I have created a solution that uses that. That is possible, but you have to remember to use the copy function. And if you have to remember to use something, there's a chance you will forget to use something. We want to make it easy to use our APIs correctly. And we want to make sure that forgetting something won't be what breaks our code. So, second attempt, we have a better talks and notes. And the main difference is that here our fields are final. And rather than set methods, we have with methods. And they create new versions of our objects with the value we passed in and the previous value for everything else. And we do the same for the schedule, create a version of that, and we show the schedule to our friend. And this time it works wonderfully because the friend said, OK, get the first talk, and then he had no other option. There was no set method, but there was a with method, which, if we check the signature, returns a version of an instance of better talks and notes. And then, again, with the schedule, he couldn't set the first talk. Instead, he could say, OK, I want a version with this first talk. So this actually works really well. The big problem here is this is a lot of code to write just to protect yourself from errors. It works fine, but who wants to have the hassle? Luckily, we can be supported by tools here. So, third version, best talks and notes and best schedule. Now you'll notice that this time we have an interface here. And this is because I'm using a tool called Immutables. Admittedly not the most creative name, but it's pretty descriptive of what it does. Immutables is an annotation processor. And I've added this immutable annotation. I've also added a style annotation, which isn't strictly necessary, but I can set a few things that I prefer. And then when I compile my code, the preprocessor will generate an implementation which is long, but all of this, 244 lines, from just these few lines plus a bit of annotation. And this is a truly immutable object. So we have the same for the best schedule also implemented, and we can create our schedule just like before. We can run, the friends can use it just like before, and of course our test works. So this way we have immutable objects without too much of a hassle. One problem with these immutable objects is, however, that you don't necessarily control all of the fields in there. So for example, here we have an immutable object defined just like previously called schedules. It's basically a wrapper object around a list of schedules that people may have. But list is Java util list. This is a mutable object. If you call list.add, you will change the contents of the list. So what we would assume is here we're creating this new array list, mutable object, and then we create our schedules, and then at a later point we get those that list of schedules. As you can see, I'm using Java 11 in this case, but it works. All of these examples work with Java 8 if you replace var with the actual type. So we retrieve our list, we add our best schedule to that list, and we would now, we'll create a new schedule since we learned that's how you are supposed to do it, and then we would assume that the schedules object here is not empty. Reasonable assumption, we just added something to it. So let's run this code, and oh dear, that's red. Unsupported operation exception, abstract list add. This is the line that threw an exception. And the reason why it threw an exception is that immutables makes an immutable copy of the list. Now, the immutable copy it's creating basically means that if you try to add something or change the list generally, it will throw this exception, which is okay, but there was nothing here to hint us towards that. If we check the Javadoc for add, it tells us this gives us a Boolean and blah, blah, blah. Nothing about this will throw an exception because you're not allowed to call it. And the compiler doesn't complain either. So this really isn't that nice. And it's not just a problem with lists. There are many, many classes that we have to use which are mutable. Now, with Java 8, we got the new datetime API, which adds immutable alternatives for date, but we're still stuck with the list, for example, or the set implementations that we had previously. Though there are, of course, with Java 11, stuff like list of, which will give you an immutable list, but it's immutable in the same way. It will throw an exception if you try to add something to it. So luckily, we don't have to reinvent the wheel because someone else has done it for us. And here we get to waiver. Now, if you were here 2 talks previously, you already saw Waiver in use for something completely different. And, well, there we go. Waiver comes, among other things, with re-implementations of all of your collections that you'll be used to. And they're all immutable. Now, they have their own interfaces, so this cannot be cast to a Java util list, but it is truly immutable, and it brings everything that the Java util list has and more, except for mutability. So we've just exchanged the type here with our waiver list, and we create an empty list. Then here we can't add to this list because add is a mutating function. Instead we append, which returns a new instance of the list, and we can check that the previous schedule still has an empty list, but the new schedule has a non-empty list. And this test will work now correctly. So, wrong direction. Immutable data. This is all fine, but surely we don't want to use functional programming all the time. I mean, functional programming, like everything else, isn't a silver bullet. So what are cases when you don't want to use functional programming? And again, I've prepared some... no, that's not it. Yep. There, when not to use. There we go. So I have a few examples, and I have one example for each of the points I made. So we'll start with declarative programming. First of all, we have here a function that is supposed to take a string and determine how many A's are in there. And I could go through what this function does, but does anyone think that this is especially readable? This is difficult to read. It was difficult to write as well, by the way. And yes, it is functional in the way that it uses lambdas. It tells the program what to do. Well, okay, there are some exceptions in there, which, well, those are side effects in a way. It's a bit weird. It's certainly not readable. On the other hand, the procedural version of this method we have here. We create a result that could throw an illegal input exception, an exception that I created. If so, pass that on in an illegal argument exception. Then, if there's no result present, return a 0, so there are 0 A's in the input, and then count the number of A's, and if that gives us an exception, then throw this exception. So here we have a case where we have several exit points in a method, and we tried to somehow get to that with this version. Now, if you saw the talk earlier about exception handling, I'm sure this could be done much more nicely using the methods shown in that talk using waiver. But using just what the Java SDK is offering us, you can't really write a readable functional version of this. At least I haven't been able to, and I don't think it's possible to write it in a way that's truly as easy to understand as the procedural one earlier. So, pure functions. Well, when don't you want to use pure functions? Well, obviously, if you want to have side effects explicitly, or if you want to depend on any kind of external input. So there are two functional interfaces in Java that are clearly meant for this kind of stuff. If we check the Java doc again, for each takes a consumer. And a consumer is of the type, it has an accept function, which is void. Now, there is one pure consumer that you can write. Yeah. There we go. This is a pure consumer. It's also utterly useless. So if you have a consumer, you will have side effects or, uselessness. So if you want to have side effects, putting them in a consumer makes it very explicit that this is what you are expecting. And as I said, functional programming is all about being easier to read. The other version of this is the supplier. A supplier is the opposite of a consumer. It doesn't take any input and provides a value. And basically, there are two versions of how that can work. Either it has a constant value, or it has some kind of dependence on external values, on a state, something like that. And this is also totally valid. Sure, sometimes you just want to return a constant value, but oftentimes you will want to have an opportunity to actually enter a value from somewhere, be it from environment variables or from the command line input or from a REST service or whatever. You do want to be able to give your program stuff, because a purely functional program that has no side effects and that does not depend on anything outside of itself, well, it can't take any input, it can't give you any output, so it can do nothing. That's not what we want. We want to be able to use these tools that Java and other languages give us. We just don't want them to happen uncontrollably. Last but not least, immutability. So what I have here is an object that will pretend came from outside. And it's a bit nasty. It's a nested object, which means it can have children of its own type. Now, what we want to do is we want to list all of the values we have in the getValue field. And since this is a recursive data structure, one idea is to go through the data structure in a recursive manner. And so we'll transform it into a waiver list, which, as I said earlier, was immutable. We'll flat map it with this method, which we'll look at in a moment, and then do getValue, and map it to getValue, and expect that these are the IDs in there. And those are the IDs that should be in there. If we run this function, however, this test, Stack Overflow. Reason being, this is the implementation. We take our nested object, make a list which contains only that, and then we append the children mapped by this function, which should work except if the object contains itself as a child. Now, this is really ugly, and these data structures do sometimes occur in the real world, sadly. Well, in the real world of software development, at least. Here we have another version of that function, and this one doesn't give us a Stack Overflow, except instead it actually works. And this uses mutability. So we have this function which creates an array list, a mutable array list of the objects it's seen before. Then it calls this second method and then returns an immutable list in the way we saw earlier of the seen before array list. And this function, which we're calling here, checks, have I seen this one before? If so, return, we're done. This is what saves us from the Stack Overflow. And otherwise, we add it to the objects we've seen before, and then repeat the function recursively on all of the children. So as soon as it encounters an object it has seen before, that's it, we're fine, no Stack Overflow. So this is a wonderful example of how you can solve something with mutability. You can solve all of this in an immutable way, but it will be much harder to read in most cases. So that's basically all I've got. Thanks for your time. The libraries I've used are visible here. Also, the link under which you can find my code. And as soon as everyone has finished taking pictures of that, I'd like to ask you to rate my talk. Thank you very much.